we've looked at solving systems of equations by graphing, and we know that when we solve a system of equations, we're finding the one ordered pair that works in both of the equations at the same time or simultaneously. And we're looking for the one ordered pair, the one x and the one y that will work in both of my equations. Graphing works sometimes, but depending on our solution, sometimes it's not the most appropriate method. So we're going to start looking at some other methods for solving systems of equations. The first one that we're going to use today is one called substitution. Substitution in mathematics just means replacing one thing with another. Oftentimes we're replacing a variable with a number, or in this instance we're going to replace a variable with an expression, but we're going to use substitution to solve this system of equations. So we're going to start by noticing that y is equal to x plus 3, which means those two things are interchangeable. So I could take, and in this bottom equation, replace my y with the expression x plus 3. Now, why would I want to do that? If I'm trying to solve an equation with two variables in it, it's much more difficult, right? It would be much easier for me to solve this equation if it had a single variable. And by replacing y with x plus 3, I'm going to have only one variable in this second equation. I'm going to have the variable x. I'm not going to have two different variables. So that's the first step in using substitution, is to actually substitute something in place of this y. So let's do that. Let's rewrite my second equation. But again, instead of putting y here, I'm going to replace it with x plus 3. And I can do that because y and x plus 3 are equivalent. They're the same thing. So I took out my y, replaced it with x plus 3. Now I have an equation that only contains one variable. And now I can solve this equation for x. So whenever we have our variable in more than one spot, but on the same side of the equation, I want to combine these, right? I'm going to combine 3x and 1x to give me 4x. And I need to solve this two-step equation. So let's get rid of the 3. And if I combine a -1 and a -3, I will get -4. Divide both sides by 4, and I get x is equal to -1. Now I'm not done with this system of equations, because remember, when I'm solving a system of equations, I'm trying to find an ordered pair, an x and a y that works in this system of equations. And what I've done so far is I've found the x. I know x is going to be -1. I've not yet found the y. How am I going to do that? Well, I'm going to take my value of x, and I'm going to put it into one of these two equations. It looks to me as though the top one would be easier to substitute into. So I'm going to take that top equation, and I'm going to put -1 in for x. So I'll get y is equal to -1 plus 3. So again, I just used substitution. I'm substituting -1 in place of this x. -1 plus 3 would give me 2. So y is equal to 2. There's my ordered pair. -1, 2 is the one ordered pair that would work in both of these equations at the same time. Or if I were to graph these, I know that they would cross each other at the ordered pair, -1, +2. So let's try another one. Again, I want to take something in this second equation and substitute. So I'll notice that x and y minus 4 are equivalent to each other, right? They're equal, which means I could replace this x with the expression y minus 4. This x and this x are equal to y minus 4. So let's rewrite that second equation, but let's replace the x with y minus 4. Now, because I'm multiplying x by 2, I need to contain y minus 4 in parentheses. So I have 2, but instead of putting x here, I'm going to replace it with y minus 4. And then plus y is still here, equal to 4. So again, I've taken this x out and replaced it with y minus 4. Remember, these are equal to each other, x and y minus 4. So I took the x out, put in y minus 4. So I have the same equation, but instead of an x, I replaced it with y minus 4. Now I have an equation that only contains one variable. It only contains y. So I can now solve this equation for y. We know that when we have parentheses, we want to use the distributive property to get rid of those. So 2 times y, and then 2 times negative 4, and the plus y is still here. So now I'm going to combine like terms. I'm going to combine my 2y and my 1y to give me 3y. So I'm going to solve this. I need to get rid of the negative 8 and the positive 8. Those will cancel. I get 3y is equal to 12. I divide both sides by 3. I get y is equal to 4. Now again, I'm not finished with this system of equations. I've only found the y value in my ordered pair. So now I can replace the y value with 4. I need to solve now for x. So to do that, I'm going to use substitution one more time. I'm going to substitute my y again back into this top equation. So I know that y is equal to 4. So now I'm going to rewrite my top equation, but in place of y, I'm going to put 4. And 4 minus 4 would give me 0. So I've now found the second half of my ordered pair. X is 0. So again, we've solved or found the one ordered pair that would work simultaneously in these two equations.